Good morning, student. Now let us discuss this theorem 2 on system of coplanar forces, which state like this. Any system of coplanar forces acting on a rigid body can ultimately be reduced to a single force acting at any arbitrary adjacent point in the plane together with a couple. So here what we have to show is that if you have any system of forces according to the proof here I've already given you, it states that like P could R be any system of coplanar forces acting at A, B, C of a rigid body. So you have this system of coplanar forces acting at different points. Say forces P here. This is force P acting at point A, force Q acting at B, force R acting at point C, and force S acting at point D, and so on. So what we need to show is that this whole system of forces P, Q, R acting at different points of a rigid body can be reduced to a single force together with a couple. So here you have, as you can see in this figure, this is a rigid body. So you have P, Q, R, S, T be any forces acting on a rigid body, and then take O to be any arbitrary point on this plane. So let me draw another figure here. Okay, so this is force P acting at A, forces Q acting at B, forces R acting at C, and forces S acting at C, and so on. So you take O to be any arbitrary point in this plane of a rigid body. O to be any point. Now consider this force. Now let us first consider this force P acting on A. So if we introduce two equal and opposite forces at O, which is parallel to this original forces acting at O, so you have to draw it in such a way, this one, such that this force is parallel to this and it must be equal to this original force, so we name it at P. And if we introduce one force, so we have to introduce to the opposite side also another same force but in opposite direction, that is P, such that these forces will have no effect on this whole system. They will balance each other, so therefore it will have no effect on this whole system. Let small p now be there. Small p be there. Perpendicular distance of this force from this line of action of the point O. So therefore you can see that these are two forces, and here you have the original forces P which is acting at O, and these two forces we introduce at O, they are equal to this force P, but they are in opposite direction. Now this given force P acting at A along with this force P acting at O in the opposite direction, they will constitute a couple. So as you can draw here, you have seen, I have discussed with you the definition of couple. So this is point O and this is point A, and this is P and this is P, where small p is the perpendicular distance between these two forces. So they form a couple. And in addition to this, so this force and this one form a couple whose moment, that is the product of either of the forces which form a couple into its perpendicular distance from the line of action, whose moment is given to be the product of either of this force capital P into small p, where small p is the perpendicular distance from the line of action of P. Now in addition to this force which forms a couple, we get another force which is equal and parallel to the original forces, that is this one. So therefore you have this force, the forces which form a couple, and another force which is equal to the original forces. Similarly for this force B, force Q here, which is acting at point B, this also can be exactly in the same way we can. Now this force Q is in this direction, so introduce again at O such that they are parallel to this original force P Q acting at A. So this is Q and this is Q. So therefore there will be no effect on this whole system because these two forces, they balance each other. So again, now take the perpendicular distance. It should be parallel this and this, okay? So therefore take the perpendicular to be distant Q, the distance of O from B. Now as you can see from the figure, this force Q force Q here, and this force Q downward acting at O, and this is B, and this is force Q. They constitute a couple whose moment is given to be Q into small q. And in addition to this, you get another additional force which is equal and parallel to the original force Q acting at B. So as you can see now, exactly in the same way, so this whole system of forces P, Q, R now can be reduced to a single force together with a couple. So thus the given system is ultimately reduced to, as you can see that this whole system of forces is ultimately reduced to a concurrent forces now, because all they are acting at their same point. These concurrent forces acting at O equal, as you can see, this force P equal to the original forces, force Q acting at O also parallel to the original forces, together with a number of couple, this number of couple, this one and this one, and this one. Similarly for R also in the same way, so whose moment are respectively equal to the moment of the individual, means the moment of these forces which form a couple are equal to the individual forces of the given system of forces about A. Now these concurrent forces acting at O, this one, if you have R also, they can ultimately be combined together into a single resultant, means this forces Q, which does not form a couple, Q, a P, Q, suppose R is in this direction, this is O, they are all called concurrent forces, and these forces now can be reduced to by taking two or three forces at a point using this parallelogram of forces. If they meet at a point, they can be combined by parallelogram of forces such that these two forces, say P, Q, can be combined into a single resultant, say R prime. Now similarly, once you get the resultant, this force R with this resultant R again can be combined together to get a single resultant R. So ultimately all these forces which does not form a couple can be reduced to a single force or a single resultant acting at point O. And similarly with this couple which form at this couple, okay, let me draw here. This forces P, this is P acting at A, and this is O at whose force P, and then this force Q, this one, force Q acting at B. All these forces which form a couple also can be reduced to a single couple, can be combined or can be combined together. This couple, all these forces which form a couple also can be combined into a single couple. So therefore any system of coplanar forces acting on a rigid body can ultimately be reduced to a single force acting an arbitrary chosen point in the plane together with a couple. Now also the result part of the single resultant. Now the result part of this, suppose of these concurrent forces. Here for this one, for all these concurrent forces which does not form a couple, you will get a single resultant. So the result part of that, suppose here the single resultant of all these three forces, it is somewhere here, okay. See, it is R. Now you can resolve these forces along and perpendicular to the X and Y axis. So the result part of this is same as will be equal to the so the result part of this three forces P, Q, R, S, T and so on, the resultant of this, you can resolve it into two forces. Any forces say R here can be resolved along the X axis, or you can write here this is force R. You can resolve it one along the Y axis and another is along the X axis. So this is R prime, and then let theta be inclination of this to the positive direction of the X axis. So this so therefore the result part of this, or the algebraic sum of this resultant of the single forces, will be equal to the algebraic sum of all the individual forces which are equal and parallel to this will be equal to the algebraic sum of each of this, which forms a single resultant. Also the moment of their resultant couple. So as you can see that we have discussed that all these forces which form a couple can be reduced to the single couple. So the moment of this combined or resultant couple that you are getting from by combining these forces of which form a couple into a single couple, so that resultant couple also, the moment of that resultant couple will be equal to the moment of the couples of the individual forces which form a couple, that is p into small p plus q into small q plus r into small capital R plus dash dash. So therefore the algebraic sum, the result part in any direction of the single force obtained above, will be equal to the algebraic sum of the result part of the system of forces in that same direction, and the moment of the couple, that is the resultant couple you obtain from here, will be equal to the algebraic sum of their individual couple, that is p into p plus q into q plus r into r plus dash dash. So this complete the proof. So hence we say that any system of coplanar forces acting on a rigid body can be reduced to a single force together with a couple, and their algebraic sum, the result part of the single resultant obtained, will be equal to the algebraic sum of the result part of the whole system of forces, that is p, q, r, obtained in that same direction, and the moment of the couple of the resultant couple also will be equal to the moment of the individual couple, that is p into small p into small p plus q into q plus r into r. So there will be a formula for this, that one will discuss after, that is called the analytical method, how to obtain a formula for this theorem, and based on that you will be able to solve many problems of forces, a system of coplanar forces which can be reduced to a single force together with a couple. So this complete the proof of the second theorem 2.